Subscribe and download over 1 million code snippet including this tutorial from codegive.com, link in the description below. Certainly. Below is an informative tutorial on PyTorch's sparse linear layer with a code example to demonstrate its usage. PyTorch provides support for sparse tensors, which are particularly useful when dealing with large datasets with lots of zero values. Sparse tensors store only non-zero values and their indices, reducing memory consumption and computational overhead when performing operations. The torch.nn module in PyTorch includes a sparse linear layer, torch.nn.Linear, that operates on sparse input data efficiently. Let's create a sample code that showcases how to use the sparse linear layer in PyTorch. Creating a sparse tensor. The example starts by creating a 3x4 sparse tensor, sparse_tensor, using torch.sparse.FloatTensor. It is converted to a dense tensor, dense_input, before passing it through the linear layer. Defining sparse linear layer, using nn.Linear, a sparse linear layer is defined with an input dimension of 4 and an output dimension of 2. Performing forward pass, the dense_input tensor is fed into the sparse linear layer using sparse_linear_layer, dense_input, to obtain the output. Output and parameters. The output tensor after the sparse linear layer is printed, along with the weights and bias parameters of the sparse linear layer. In this tutorial, we learned how to use PyTorch's sparse linear layer to efficiently process sparse input data. Sparse tensors can significantly reduce memory usage and computational overhead when dealing with large datasets with sparse features. Experimenting with sparse tensors and layers can be beneficial for tasks involving high-dimensional, sparse data like natural language processing or recommendation systems. ChatGPT.